Today we're going to discuss about an important topic coming in the experimental design subject. We consider about the mean separation procedure today. Then we have discussed a lot of experimental design models. We started with complete randomized design, then we improved it for the randomized complete block design. Then we discussed various application with respect to CRD and RCPD. Then we discussed Latin square designs either. Then we have skipped one part. Then but in those all steps I have taught you that if we have rejected the null hypothesis and take the alternative one, we need to examine what is the different group or what are the different groups. So today we are going to learn how to do that step. So after completing this one, you can go for the examples we discussed in the previous lessons, and if you have rejected the null hypothesis and accept or take the alternative one, you can conduct these tests at there. So normally we call it as the Posthock test. Posthock test. Okay, let's see what the slides say. Mean separation procedure. The information gained from ANOVA is that whether all means are same or at least one mean is different. If it is so, it is not obvious which treatment mean is different. On the other hand, it is also possible that all means are different from each other or same means are different or some means are different. These situations cannot be distinguished from ANOVA. In order to know how means are different from each other, a mean separation procedure is adopted after performing ANOVA. So it's important. Then that will improve the conclusion. Then that will improve more information which are finding along with experimental design. Okay, this is a simple step. For first step, you can plot your data set in this way and you can see some idea about that, but that's not the definite idea. We have to conduct a post-hoc test to check whether these are different or not. Anyway, this is the null hypothesis. In null hypothesis, we say the mean of all considering groups are equal. In the alternative one, we say at least one is unequal from others, or sometimes there may be more than one different means. So we can check. Let's see, if you have rejected the null hypothesis by ANOVA, then these questions are arising. Which one different? What is the different group? Or one must compare pairwise. So each one we need to consider for the comparisons pairwise. Let's see. Then the null hypothesis, the H naught. H naught means this kind of a thing. Hypothetically, we have assumed here there are three groups. So let's say about those three are A, B, C. Then you can say there are three groups A, B, and C. Then what we have plotted here, the mean. You know how to calculate the mean. We can add up all observation in the group and we can divide the sum by the amount of observation for the group. Then after doing that kind of a thing, we can find means for all group. Then here it has plotted. Then when you come into the alternative one, that says at least one may be different. So what in this first graph, the first group is different than the other two. The B and C are equal, but A is somewhat different from A and B. So in this graph, what it says? Yeah, it says A and B, mean of A and B are equal, but C is different. Then in this graph, A and C are equal, but B is somewhat different from A and C. But in here, all three are different. There is no any equal mean. A is different from B and C. B is different from A and C. C is different from A and B. So this is the story we are going to find, but the graphical interpretation is not enough because we considering the variance also in the ANOVA more than when you are writing the model. Uh, more than the mean, we consider more information. So this is only about the mean. So we have to conduct Posthock test. Then first we need to decide how many comparisons are available. Then in general, you can use these equations to have an idea. Then this is about the number of possible comparisons. In general, for an independent variable with k groups, the number of possible comparisons is given by this. Then you can identify how many groups in your design. Then that times the amount. This is about, I will use my highlighter. Yeah, k is about groups. K is groups. Then suppose in the previous example there were 3 groups, so it is coming in 3 times 3 minus 1 divided by 2. Then how will be the answer? 3 minus 1 means 2. 2 times 3 is 6. 6 divided by 2. Answer is true. 3. Then when we have 3 groups, we will have 3 comparisons. Then let's see what are those. We can compare. There were 3 groups called A, B, 3. A with B and A with C and again B with C. These are the possible comparisons. Then if you have any idea more than this amount, you can state your ideas. Okay, now we are going to discuss the first test in the Posthock analysis. Least significant difference test, LSDT. In short form, we call it as LSDT. So in the expanded way, we can say least design least significant difference test. Give me a minute. This test has described by Fisher in 1960. One of the oldest, simplest, and most widely misused multiple pairwise comparison test in the least significant design test. So LSD is based on T test. So you need to remember how to read the T table because it is based on the T test. In fact, it is simply a sequence of many T tests recalled formula for the T statistic. So this is the way of calculating T statistic. You will remember. Then this is the way of calculating the statistic of least significant different test. This T statistic is distributed according to a T distribution with R minus 1 degrees of freedom. The LSD test declares the difference between means. So actually you can use these formulas rather than these things. This T statistic is distributed according to a T distribution with R minus 1 degrees of freedom. The LSD test declares the difference between means yi bar and yj bar of treatments I and j to be significantly different when yi and yj the absolute value of this difference is greater than LSD. So this is the way of calculating LSD statistic for the unequal R's. So for the unequal draws, for the separate comparisons, you need to apply this, you need to calculate this test